All right. Welcome back, everyone, for another deep dive. And today, we're diving into something pretty spectacular. I mean, I know a lot of you are probably already following this story pretty closely, but we're talking about the Parker Solar Probe.
Absolutely.
And its recent close encounter with the sun.
It's a hot topic.
Yeah, I mean, we're talking about something that dipped into the sun's atmosphere.
I know.
So we're gonna unpack just how groundbreaking this mission is and what it's teaching us about the star that makes life on Earth possible.
Well, thinking back just a few days ago, December 24th to be exact, the probe made this daring maneuver, this close approach, and we all had to wait.
Oh, yeah.
With bated breath for 2 days for it to reestablish communication.
Right.
And then, thankfully,
oh man,
December 26th, we got confirmation.
it's alive.
It survived. It had survived its closest approach yet, coming within a mere 3.8 million miles of the sun's surface.
That's incredible. 3.8 million miles. That still seems so far.
Yeah.
But I guess in the grand scheme of things.
In the grand scheme of the solar system, yeah, that's right there.
Yeah, and I was thinking about it. This probe's been on this journey since 2018, right?
That's right. It was launched in August of 2018.
That's a long time. So it's like we're just now getting to the really good stuff.
It is. It's finally getting to do what it was designed to do, and that is to get up close and personal with the sun.
So what is it that this close proximity allows us to study that we couldn't from further away?
Well, one of the main things we're really interested in is the solar wind and studying it right where it originates from. So the solar wind, as you may know, it's this constant stream of charged particles that blasts out from the sun, and they travel at nearly the speed of light, impacting everything in its path. And this is happening all the time.
That's amazing. I always thought of the sun as like this giant ball of fire just sitting there.
Yeah.
But it's incredibly active.
Oh, it's incredibly active.
And it's constantly blasting stuff at us.
It is. Yeah. It's not just light and heat. It's all these particles that are coming at us all the time.
So this solar wind, it's coming at us at the speed of light. I mean, did that have any tangible effects here on Earth?
Yeah, it actually can have some pretty significant effects. It can disrupt satellites, which we rely on for communication and GPS.
Oh, wow.
It can cause communication blackouts, and it can even pose a threat to astronauts who are outside the protection of Earth's magnetic field.
That sounds pretty serious.
Yeah, so understanding the solar wind is really crucial for us to be able to protect our technology and our astronauts, and just to prepare for future space exploration endeavors.
Absolutely, because if we're going to be sending people further out there,
right,
we need to understand how to deal with this.
Absolutely. It's part of what we call space weather. And just like we have to pay attention to the weather here on Earth, we have to understand space weather to make sure that our astronauts and technology are safe.
So speaking of speed, this probe reached an incredible speed during this flyby.
Oh,
it was something like 430,000 miles an hour.
430,000 miles an hour. Hard to even wrap your mind around that.
I mean, I try to put it in some perspective, right? It's like, if it were traveling over the Earth, it could cross the entire United States.
Wow.
In under 2 minutes.
Under 2 minutes.
It's mind-boggling.
Right.
But how does it survive that heat? It's so close to the sun. I mean, it must be unbelievably hot.
Yeah, that's where the real ingenuity of this mission comes in, and that's the heat shield technology. So it's made of this really cutting-edge carbon composite material, and it's designed to withstand temperatures reaching 2,500 degrees Fahrenheit.
2,500 degrees.
Yeah, it's mind-blowing.
That's hotter than
anything we experience here on Earth, right?
Oh, absolutely.
And so what it does is it acts as a barrier, right? It protects the instruments that are behind the heat shield.
Ah, I see.
So they stay nice and cool at 85 degrees Fahrenheit.
Wow, so you're talking about a temperature difference?
Yeah.
Greater than the range of temperatures we experience here on Earth in a whole year.
That's right, yeah. It's just an incredible feat of engineering.
So all this data the probe is gathering at these incredible speeds, what are we actually learning?
One of the key things that we're really trying to understand is, how are these particles in the solar wind accelerated to such incredibly high speeds?
Right.
Right? They're coming out at nearly the speed of light. How does that happen? What are the processes that are driving that? Current theories suggest that turbulence and magnetic fields play a role, but we need more data, more measurements to be able to really confirm these hypotheses.
Yeah. So what kind of data is it actually collecting to tell us about that?
Well, it's measuring the magnetic fields, the electric fields, the plasma itself, the particles, all of these things to try to piece together what's actually going on.
It's like having a little laboratory.
It is.
right there in the sun's
A
atmosphere,
little science lab.
just collecting all this information.
Yeah.
That's incredible.
Yeah, it is. And it's giving us these unprecedented insights into these complex processes. We can't recreate those kind of conditions here on Earth, so we have to go out there to measure it.
And that's what makes this mission so important.
Absolutely.
Yeah. I almost forgot, we can't leave out one of the big initial goals of this mission, right?
Oh, yeah.
To solve that mystery of why the sun's corona, its outer atmosphere, is hundreds of times hotter than its surface.
Yes. It's one of the biggest mysteries in solar physics. It just defies the laws of physics as we understand them, right? You'd think the closer you get to a heat source, the hotter it gets.
That's what I would think.
Exactly. But with the sun, it's the opposite. The surface is thousands of degrees.
Right.
But the corona, which is millions of miles out, is millions of degrees.
That's crazy. And there's still no solid explanation.
Well, there are a lot of theories. It's been a puzzle that's baffled scientists for decades. And there are some promising ideas out there. One of the most prominent ones involves these things called nanoflares. They're these tiny explosions that happen on the sun's surface, and they release bursts of energy. And the idea is that they might be contributing to heating the corona. But we need more data, more evidence.
Right, because those are just theories.
Exactly.
So we need to get the evidence to prove them or disprove them, I guess.
That's exactly right.
And the Parker Solar Probe, hopefully, will help us do that. So it's like we have a front row seat to a cosmic fireworks show while simultaneously unraveling some of the universe's biggest mysteries. It's incredible.
That's a great way to put it. And it really does make you wonder what other, seemingly insurmountable challenges we might overcome in the future.
Right, absolutely.
If we can touch the sun, what else is within humanity's grasp? What other boundaries can we push?
I love that question. Because it's true. I mean, we went from launching this probe in 2018, waiting on bated breath for its survival,
right,
to now, years later, having all this incredible data that's helping us to really understand the sun in a way we never have before.
Absolutely. It's a testament to human ingenuity.
It really is.
And the power of science and exploration.
Well said. It's a fantastic story. I encourage all our listeners, go delve deeper into this mission, its findings. There's so much to learn. But that's all we have time for on this deep dive. Until next time.